Welcome to my channel, RAVIKUMAR Academy. This is the lecture series on single variable calculus, and in this lecture, we are going to learn Cauchy mean value theorem, statement, and problems on verification of Cauchy mean value theorem for a given function. What is Cauchy mean value theorem? You are given two functions, f and g, such that f and g are continuous on the closed interval, f and g are differentiable in open interval, and g dash x is not equal to 0 for all x belonging to the open interval AB, then there exists at least one c in the open interval AB such that f dash c by g dash c equal to fb minus fa by gb minus ga. This is the statement of Cauchy mean value theorem. So what is required here is here you should be given two functions f and g and an interval AB. Here we are given two functions e power x and e power minus x in the interval AB and asked to verify Cauchy mean value for theorem for this given functions. Here what is f of x? F of x is e power x and g of x is e power minus x in the interval a comma b. Now let us find the derivatives first. F dash x is e power x and g dash x is minus e power minus x. The derivative of e power minus x is e power minus x multiplied by inner derivative of minus x is minus 1. Therefore, you will get minus e power minus x and x belonging to open interval AB. Remember, exponential function is a very good function. It is always continuous, differentiable, integrable, everything. So, we need not check. Every exponential function is differentiable in all, right? So, therefore, f comma g are differentiable. So you can also write like every exponential function is differentiable and continuous everywhere. Therefore, it is g of a, f and g are continuous and differentiable in AB and that in that way you can also write the conclusion. Differentiable and continuous in the interval AB. And what is the third condition of Cauchy mean value theorem? G dash x is not equal to 0 for all x in the interval. But what is g dash x? G dash x is minus e power minus x. And exponential function is never 0. We have seen it in the previous videos. Remember this point. This is very important. Exponential function is never 0. For any value of x in the real line, e power minus x or e power x will never be equal to 0. Therefore, g dash x is not equal to 0. Right? E power x is not equal to 0 for any x. So g dash x is not equal to 0. That means all three conditions of Cauchy mean value theorem are verified, true, for these two functions. Therefore, there must exist a C in open interval AB such that this happens. So, verify means what? We need to verify whether it is true or false. That means we should be able to find such a C. Right? Now, let us consider f dash C by g dash C equal to fb minus fa by gb minus ga and find C. Okay. What is f dash c? F dash c is e power c because f dash x is e power x by g dash c is minus e power minus x. F of b is e power b, f of a is e power a. G of b is e power minus b, g of a is e power minus a because g of x is e power minus x. Right. So from this we can write minus e power c into e power c because so we have e power minus c in the denominator. Therefore, you can write this as e power c into e power c. E power minus c will come to numerator equal to f of b is e power b minus e power a divided by this e power minus b can be written as 1 by e power b. This can be written as 1 by e power a. So you can write 1 by e power b minus 1 by e power a. So which is e power b minus e power a multiplied by 1 by, you can write e power a minus e power b by e power a into e power b in the denominator, LCM. And you can write this e power a into e power b goes to the numerator. It is e power b minus e power a into e power a into e power b by e power a minus e power b. Right? So this is minus e power 2c. But you can write this e power, you have e power b minus e power a. Here you have e power a minus e power b. So let us take minus common here, e power a in a plus b, this is divided by minus, you can take common, it is e power b minus e power a. So this thing, these two things cancelled, minus e power a plus b is remain. So, and this negative sign and negative sign also gone, e power 2c equal to a plus b, sorry, e power a plus b, and you equate the exponents because bases are same, equate the exponents, you will get c equal to a plus b by 2. So whatever Cauchy claimed that you can find a c in between a and b, we have found it, right? Because a plus b by 2 lies in between a b, in between a and b, right? Midpoint. So therefore Cauchy mean value theorem is verified. Is verified. Verify Cauchy mean value theorem. Now we are given fx equal to log x to the base e and gx equal to 1 by x, and x belongs to 1 comma e closed interval. Now what is f dash x? The derivative of f dash x is 1 by x, and g dash x is minus 1 by x square. Derivative of 1 by x is minus 1 by x square, and x belonging to 1 comma e. So here f dash and g dash both have a troubling point at x equal to 0, because denominator shouldn't be equal to 0, but when at x equal to 0, the denominator becomes 0, right? But x equal to 0 is not there in the given domain. Therefore, f dash and g dash are well defined in 1 comma e. Therefore, f dash comma g dash are well defined in the interval 1 comma e. So f comma g are differentiable. F comma g are differentiable. In fact, in closed interval AB also it happens, but we need it in 1 comma e open interval. That is sufficient, but we have more than sufficient. More than sufficiency, we have differentiability in closed interval also. So f comma g are continuous in open interval, closed interval AB also. That means closed interval 1 comma e. And also, what is the third condition? Third condition is g dash of x. G dash of x, what is g dash of x? It is minus 1 by x square, and it is never 0 for all x belonging to 1 comma e. Whatever number you take in between 1 and e, it won't be equal to 0. Right? It's clear. Therefore, all three conditions of Cauchy mean value theorem are satisfied. This implies there must exist a c. That means we have to find this c, right? In the open interval 1 comma e such that f dash c by g dash c equal to fb minus fa by gb minus ga. But what is f dash c? F of x is log x. F of x is log x. F dash x is 1 by x. G dash x is minus 1 by x square. So 1 by c by minus 1 by c square equal to f of b. F of b is log b. F of a is log a, of course, to the base a e. G of B is 1 by B minus 1 by A. Now, what are A and B? Here, A and B are 1 comma E. The interval AB is 1 and E. Therefore, log E, B is E, minus log 1 by 1 by E minus 1. So this is 1 by C multiplied by minus C square by 1 equal to log E is 1 minus log 1 is 0 divided by 1 minus E by E. This is 1 into E by 1 minus E. I write it as minus of E minus 1 because E is greater than 1. So you have negative sign here and here, you can cancel out. 1 C square, 1 C gets cancelled. C equal to E by E minus 1. So what is E by E minus 1 value? It is 2.7 divided by approximately 1.7. It is approximately 1.58 and it lies between 1 comma E. It is greater than 1 and less than 2.7. Therefore, it lies between 1 comma E. Mission successful. As Cauchy told, we are able to find a C in between 1 and E for which this is satisfied. Right? So therefore, Cauchy mean value theorem is verified. It is verified. So coming to this problem, we are asked to verify Cauchy mean value theorem for the functions root x and 1 by root x in the interval 3 comma 5. What is f dash x? F dash x is 1 by 2 root x. And what is g dash x? G dash x is, because this is x power minus of, what is g dash x? It is minus of into x power minus of minus 1, which is minus 1 by 2 x power minus 3 by 2, which is minus 1 by 2 into x power 3 by 2. X power 3 by 2, you can write x root x. So for both g dash and f dash, the denominator becomes 0 only when x equal to 0. And if 0 is not there in the given domain, then f dash and g dash are well defined. And clearly, because the interval is 3 comma 5, as 0 is the only troubling point, does not belong to 3 comma 5 interval, f dash and g dash are well defined. They are well defined and f and g are differentiable. F comma g are differentiable in the interval 3 comma 5. Differentiability implies continuity. Therefore, f comma g are continuous not only in the open interval but also in the closed interval. Also, they are continuous. So, and also, what about the third condition? Third condition is g dash x should not be equal to 0, right? But what is g dash x? It is 1 minus 1 by 2x root x. And minus 1 by 2x root x is not equal to 0 for all x. Whatever x you take in between 3 comma 5, between 3 and 5, it is not going to become 0, right? In fact, for any finite value of x, it won't become 0, right? Therefore, all three conditions of Cauchy mean value theorem are satisfied. So we can find such a C, right? There must exist a C, as Cauchy told, in between 3 and 5, such that f dash c by g dash c equal to fb minus fa by gb minus ga. This is what Cauchy theorem states, right? So we need to find out such a C, taking this one. So what is f dash c? F of x is root x. F dash c, f dash x is here. F dash x is 1 by 2 root x. G dash x is minus 1 by 2x root x. So f dash c is 1 by 2 root c. G dash c is minus 1 by 2c root c. Fb is root b minus root a. Fb minus fa by gb minus a, 1 by root b minus 1 by root a, because g of x is 1 by root x, g of b is 1 by root b minus 1 by root a. So it is root b minus root a divided by, you can take LCM here, you can write root a minus root b by root ab. And you can write this as root b minus root a into this ab, root ab comes to the numerator divided by root a minus root b. I write root a minus root b as minus of root b minus root a. Right. Now these two are cancelled. This is minus root ab. And what about the LHS? LHS is 1 by 2 root c multiplied by minus 2c root c by 1. So 2 gets cancelled, root c gets cancelled. You will get minus c. Minus minus gone. Therefore, c equal to root ab. What is root ab? Root ab is geometric mean of a and b. Geometric mean or arithmetic mean of two numbers will always lie in between those two numbers. So yeah, we have successfully found a c in between a and b, which is root ab, for which this happens. That is what Cauchy told. Cauchy theorem states. Therefore, Cauchy mean value theorem is verified. Hence, Cauchy mean value theorem is verified for these two functions. Okay. So this is how you can find, you can solve, or you can verify Cauchy mean value theorem for any given function. Right. Please subscribe to my channel if you have not subscribed. Like the video, share it with your friends and classmates. Comment your feedback in the comment section. Thank you.